And when you talk about this traditional medicine, they are observational, right, and anecdotal. But they do not match the rigors of science unless we apply it today, right? You do a blind clinical trial, the double-blinded trial. There are established criteria for acceptance. So until they meet that, can you actually call them treatments? Because it's like today, say my uncle took this Ayurvedic herb, he had this problem, he's cured. So that becomes a truism. But is that true? Considering now we know there's a 30% placebo effect. If I take two groups, this is a key.
All right, yes.
Right? So the psychosomatic component we don't understand, but there is a placebo effect. So now do I then believe anecdotes about traditional medicine? Not to say there is nothing, because we know there are potential drugs in plants. I mean, many of them have been isolated.
Yes.
So it's quite likely they have activities. And in fact, today if you go to an Ayurvedic fellow, he will tell you it cures cancer. Those days they didn't know what cancer was, right? So is that actually science?
It has happened.
Or hasn't yet crossed the threshold of science? Sorry?
A lot of drugs have been discovered, activities have
That
been
part is
discovered
science.
by going back.
But going by the scriptures for traditional medicine, do you consider that as science in the absence of rigorous validation?
Well, basically we have to understand why we call it traditional knowledge. What is the traditional knowledge? What is the modern knowledge? And what is the knowledge at all? First, we have to understand what is the knowledge at all. So even whatever comes information or understanding through a science, that become a knowledge.
Correct.
So science also at the end up as a knowledge. And in science,
No, but important distinction. Yeah, science contributes to knowledge, but all knowledge is not science, right? I may know the history of India, part of my knowledge. It's not science. Science is the knowledge gained through rigorous validation, right? I think that is an important component of science.
and to all the backbone of entire process, scientific process, is observation.
Absolutely, yeah.
That is the backbone. Observation. Whatever you do, cross check everything. You
correct.
observe every time.
Correct.
It's based on observation. Similarly, information that is based on like a manual observation again and again and again and again. Now that's become like a traditional therapy. But that is also based on knowledge. Observation.
Correct.
Now it's become a part of knowledge. So the big question is, why one thing which is based on observation, we call it science, while the other thing which is also based on observation, we don't call it science.
No, I'll tell you the difference is this. The observation will generate a hypothesis, right? So the literature says you mix these 20 herbs and boil them for 5 days, which is how Ayurvedic components are made. It will treat whatever disease you want to pick, right? But that is observation, and you have no information on the basis of that observation. And what I mean is, how many individuals were studied, on how many did it work, on how many did it not work, numbers that it worked.
This was not done, but not just not recorded. Who is to say that this was not done?
Yeah,
Might
no.
have been done,
So when
but not
you're
recorded,
ignorant
just
about the
not
value,
for us to
do you consider it as science unless you retest it for yourself?
Yes.
I'm not saying, my argument is not that you should discard it, but perhaps, we need to validate it, right? If something says in a text, you actually do a clinical trial.
Again, if it's not available.
Maybe
We go a little bit further than just validation. We also try to establish causality.
That of course.
XYZ disease
Yeah.
is affecting at that very location. This is the cause of it. This particular
Correct.
medicine
Yeah.
happens to take care of that very cause.
Yeah.
So unless, so validation maybe 10 people came
Yeah.
and they all got better by taking that medicine.
Statistic, number of studies, correct. That at least, verifies use. I mean, see, the myth we have, let's finish one thing. The myth we have is that Ayurvedic, for instance, you say Ayurvedic medicine, we have been taking it for centuries, is completely harmful. That is absolute trash. Actually, many of the Ayurvedic formulas are extremely toxic. We have never tested it. So today you do a classical pharmacology test, most of them, actually there is no way a complex mixture cannot harm your liver. Because you have this, the liver actually is where everything is degraded, and there are classical assays, they call the CYP assays. You look at about a panel of 8 to 10 CYP isozymes, and the moment you put a complex mixture, you have a problem there. And so when you have these plant formulations having thousands of molecules and you say it's not toxic, highly improbable. Sorry, yeah.
Yeah, so I would like to give an example from thermodynamics. Okay, so if you look at classical thermodynamics, okay, you believe from certain set of experiments, you say the entropy is increasing, and you know the universe is becoming more chaotic. Okay, so let's say if I'm in working in framework of classical thermodynamics and taking those axioms and then building my theory based on those axioms or applying those axioms or the laws, okay, then would you not call it as science? I'll call it as science.
Sure.
Okay, but if you delve further into it and now you go into statistical mechanics, you'll say, no, the gas, if you have molecules of gas, they may not occupy the whole volume. There is some finite probability that they might collapse just because there's more probability for them to capture the whole volume of a cylinder, let's say. Okay, so for every like scientific field, I think that there is certain axioms, you know, which the experiments have not failed, have not said that from experiments you haven't proved that they are not failing. Okay, so now for example traditional medicine, okay, so they are given as axioms. Okay, so I may not look at the pathway by which they are acting, but just like I work on classical thermodynamics, I might assume that okay, this is right, and now if I test, if it gives the results, I will say okay, this is science. But now, you know, a physicist like a statistical mechanics person, he will say, no, this is not the right way because we can challenge that. So I think that it is genuine, it's fine to challenge, but you can't you can't take away the fact that
It worked.
through centuries and thousands of years,
It worked.
it worked.
No, that is my fundamentally I'm questioning.
That's-
How do
that's
you
what
know
it
it has
was to
worked?
me.
What is the evidence
No,
that it
The
has
question
worked?
is that every time, let's say I teach in class, let's say laws of thermodynamics, we don't do the experiment and say the work is equivalent to heat. We don't do those experiments, okay? So we assume that someone would have done those experiments and passed on those laws which we treat as true, okay? So now if you construct an experiment saying that, look, you know, if I take these many molecules and it is collapsing, you can't say that thermodynamics is wrong.
Wait, do you know many of our Ayurvedic drugs are now banned in the West? Many of our Ayurvedic drugs. No, I'm just saying, because they're highly toxic. Some of them have a lead content, some of them have. So this is the problem. So today our methods for evaluation are far more rigorous. And why is India losing out completely? Because China decided 15 years ago they're going to do it thoroughly and rigorously. They've finished all their natural medicine. Today if I'm in Europe, I'll buy Chinese, never touch Indian. So we have lost the market, we have lost even the conceptual leadership we had because we just kept saying it was done 3,000 years ago. So it's good enough for us. That's the fallacy.
Yeah, basically yes, you know, we don't need to challenge it, but whatever fact is
not challenge, evaluate it.
Exactly, we
Evaluate
shall evaluate it.
You might say there
we shall
are some
evaluate it.
toxins which come during the process of making those drugs, fine. But there might be a molecule which might be acting as a drug. So what you can do is that you can separate out that
Single thing
molecule.
out.
Single
Correct,
thing.
correct.
But
That's the
Not
process
only
that we
that,
need to
yeah.
do.
And-
Yeah.
But that doesn't say that this medicine doesn't work. So
no,
we can take a clue and then, I mean, we can take a clue from that traditional knowledge, okay, and then because it has some backing to it because someone would have done and
Sure.
certainly written it, so we can work on that. So there need not be
No,
some.
I completely, no, there's no confrontation. No. No, the only argument is there is a traditional literature which says these formulations work. What we need to do today is rigorously validate them. You know, for instance, a few years ago we did a major project for PepsiCo. Because Indra Nooyi, who's the CEO, she was interested. She was looking ahead and saying, there's not much future, obviously, for junk food because people are health conscious. So she was thinking in terms of this notion of wellness foods, right? Because Pepsi's major market actually is things like oatmeal and not the beverage. And since she grew up in Chennai, she had this idea, why not try that? So we got this project, and this is something she was very passionate about. So we did a lot of testing of many of these Ayurvedic, and to be very honest, what we finally gave back to them was a Chinese preparation which works beautifully. And we tried about 20 Ayurvedic formulations. All of them worked well, but toxic. So I'm not saying again that because you don't discard. See, we address the problem and fix it. So you can remove the toxic components, still make it, but simply because it's recorded 3000 years ago to accept it, particularly given that today, see, times change, right? We talk about Pasteur's vaccination strategy, right? He just went and injected a guy. Today you do that, you're in jail,
You're in jail,
right?
absolutely.
So you have to evolve with the times. When we talk about thermodynamics, biological systems was a classic violation of the third law, right? Because everything evolves towards higher order rather than disorder.
Chaos.
And that's how actually this coupled reactions were discussed. So you have, for every reaction that decreases entropy, it's coupled to a reaction with entropy increase. So that kind of balances out.
Yeah.
So
The question is that, you call it science because like I think that, science is like this antigen binds with antibody, let's say. I would call it science. But how I apply that science to, let's say, create an amino assay or something, do you call that as science or an
science or
art?
technology?
Yeah,
What would you
so
Technology.
technology, right? So
Yeah.
now I would consider that the science is that this molecule has this some effect, okay? So it has some effect on the body and whatever the pathway, so that would be science. But the way you are applying that, I think, falls in the regime of technology.
Sure.
So that is something that we should distinguish.
Oh, absolutely. Yeah, absolutely. Yeah. And in fact, that is the question, right? Today, the emphasis on not figuring out how antibody comes or is made, but how can I use it to diagnose a disease, right? So,
Question I would like to point out is that as a scientist, we should also understand what are the limitations of science. In a way that I might like the color yellow, he might like a color blue, let's say, and you can't say that yellow is the right color.
Correct.
So, right. So and that is the reason the beliefs come into play, because I might have a theory in my mind. I'll use science to reconcile with that theory and think that okay, now I'm happy. But he might follow a different belief.
Correct.
So I don't know if by using scientific arguments we would be able to answer questions of belief, because there are some things that at this point science is not able to explain, even simple things that why do I like a particular kind of fashion on.
absolutely, yeah.
Like one, very clear distinction between science and belief, what we understand. That science believe on something which can be tested, which can be validated, and that can be, it can be experimentally shown. While we say belief, we believe it, even we cannot prove it. That's the major definition of that.
More importantly, it can also be replicated deterministically.
Exactly.
Yeah.
Of course,
Within the uncertainty of probability, right?
So basically, we know there's a very broad definition of the belief or religion and what the science. That is the major difference. Now we have a very famous equation by Einstein. E is equal to mc square, and we tend it to be correct. Where if that much of amount, you destroy that much of amount of mass, it will create that much of energy. That's true. But have we been able to amass that much amount of energy to create that much amount of mass according to that equation? So far as I know, nobody have shown it experimentally. There is no proof that if you use this much of amount of energy, you will create this much amount of mass according to this
Kedar, you
equation.
have I don't know
Yeah,
the
it's
answer.
also
to
good
Kedar
to
should
look
be able
into
to answer
You
that.
have an answer.
So far the science doesn't have an answer. There is no experiment, there is no experimental proof.
But science doesn't claim to or even want to answer everything. It's a process of inquiry leading to
Exactly.
That's
serial
true.
sets of answers
But
of
that's
different.
true. But as long
degrees
as
of-
there is no experimental proof, there is no experimental evidence,
It's only hypothesis.
why we believe
It's a
it?
hypothesis.
No, it's only hypothesis.
It's a
No.
hypothesis.
I know. So if you
But
look
why
at
we believe this equation is true?
We don't.
It accounts for whatever set of observations we have now, right? Take the classic case of the Higgs boson, right? It was a particle. See, correct me if I'm wrong. Yeah, which explained how mass was generated. Is that right? Right? And it was a hypothesis. But recently they detected it, and even when they detected it, CERN announced whatever sigma factor, which is a probability factor, 99 point whatever it is. Yeah, so nobody will say it is there, it's probably there with different degrees of certainty.
But in science book, in our training, we treat it like a belief, we treat it like a truth.
Sure.
That's why we have been taught. The big question is, if we don't believe we don't believe is a truth, then why we teach it? Why we don't simply reject it?
No,
The
but
statistical aspect is again important.
yeah, I think that is the cornerstone of at least experimental science. Yeah. I don't know how it works in astronomy and others, or sociology for instance. I don't know, how do sociologists handle this question? Because for you, proving a hypothesis is much more difficult, right? Or is it?
I would say my sociology colleagues tend to look at samples.
Sample
They tend to-
size.
Statistical investigations are very, very important, and so they wouldn't make the kind of sweeping generalizations
Right.
some of the humanities would want to do. There has to be a proper basis in sample
making
size
that.
and so on.
Right,
So,
right.
something
Yeah.
similar to what Kedar is saying.
But with-
But that's a more hard-nosed science, social science compared to us.
Okay.
But uncertainty is not even in experiment, not only in experiments, because now with quantum theory you have uncertainty
Sure.
in
Yeah.
the axioms also.
Okay. Quantum theory, then there's the chaos issues comes in. Nothing repeats itself twice in ever, right? So I think. So, but do I need to reject something? Do I need to reject something that I'm not sure is the truth? I mean, isn't all of this part of me that makes me think, question, and so on? Because I honestly don't know what is the truth, and even if you tell me this is true, I don't know. See, I accept DNA as the basis of genetic material because I've been taught that's the key. I agree with you, but the fact is, beneath that there's a whole body of evidence, right? I mean, a teaching system is didactic because right in the 7th, 8th standard, your teacher can't go back to the whole history of how DNA was discovered and Watson and so on. So whatever you're taught to believe, you're sure that there is actually a body of evidence behind that which supports that belief or idea or whatever you want to call it. So that I think is another important feature, because although it's a didactic thing, but that evidence is there. So that's another important distinction.
Yeah, that's true. But in science, in certain things are backed up by evidences, but there are many things which are not backed by evidences.
As yet.
Sure. Yeah. But then nobody takes that. That is a hypothesis, right? That's a hypothesis. That's an idea set, right? So in that sense, I could even take God as a hypothesis. It actually is a hypothesis in a way, right? So I take a hypothesis with a pinch of salt unless evidence accumulates to back its validity. If I take that, then I guess I don't know.
So what accounts for scientific revolutions in that sense? And so you mentioned Kuhn. And what?
So what is
piecemeal? You're moving
It's
along a certain
piecemeal.
path.
So yeah, what?
What counts for a sudden event of shift?
Correct. So it comes back to what Kedar had said earlier, is that in any hypothesis there are always anomalies, and sometimes when you investigate those anomalies, you're forced to break the past, the framework of that paradigm, and suddenly there's a complete change in perspective. I mean, some would argue he went a bit too far, but certainly, because he would say actually there's no relation between you speak two different languages. It probably happened a couple of times in physics. So same Newton, Bohr, quantum theory, and so on. But that's so when the anomalies force you eventually over years, it can be decades, to break down your early hypothesis and create a new one. So a lot of it is actually exploring the anomalies, and either you can get them to fit into the real model, or completely radically change.
Carl Linnaeus was a revolutionary in that sense. All he's done is been able to come up with a nomenclature for species, but at that time everybody looked at different species and had no system of calling them names. This guy was the first one to think, okay, why not use two names, put them together, a species and a genus name, and they would be rationally decided. And then Bentham Booker followed it up. And today we have instead of a hobby being plant science, of course for animals it was followed up also. Rather than plants being a hobby, it's now a full-fledged scientific discipline. Because this was the first guy who thought, all right, there has to be a way in which I can talk to somebody or write a letter to somebody or communicate with somebody about a certain plant. A rose is a rose by any other name, but if it's not got that name, how do I tell you to go to that plant and, smell a rose? You have to be able to think that it has to have a common way so I would believe that kind of revolutionary thought would have happened. Today we think it's part of the natural set of things. Okay.
Or before that, even Darwin, for instance,
Yes.
Intelligent design, we were all created by design as opposed to we all evolved. I mean, it's a huge, complete mindset change. So that's another huge paradigm. Sorry, Kedar. Yes.
So the revolution, other thing is that certain question which was not under, say, scientific realm, suddenly becomes investigatable by science,
Yes,
scientific
sure.
methods. That I would call as revolution.
But the challenge seems to be, it's not that you're not aware of the problem. If you take the amount of money required to solve all those problems, so you have a small kitty, how do you put it? And that's where the debates come. It's always, no matter what you do, it's an unsatisfactory or incomplete solution, But apart from that, but coming back to science, I mean, how well do we understand what the essential nature of science, and can we communicate, articulate it, forget to politicians, to a layperson, right? The increasing interpretation of sciences, you will benefit me somehow. But the intangible benefit of just understanding the world we live in, do we recognize the value, and can we communicate it, articulate? Say if you went home, let's say you have a brother or a sister who's not in science, can you communicate to him or her, what is the value, what do you do beyond, say, I'll cure cancer or whatever disease you're trying to cure, malaria, right? You're trying to cure malaria. So beyond that, can you communicate, well, it's the fun of knowing how,
We need to have a perception of science in the society, irrespective of the career science, the profession of science. That needs to be encouraged.
Yeah, that's true.
Indeed.
It has to be, the common masses as well. But
How often do we chat with our friends and talk about science? We talk about everything under the sun, about movies, let's say, but how
But
often?
it is interesting. Can we actually talk science in a lay language, right? We are losing that capability. I'll give a simple example. I don't know if I'm wasting time, but there was an institute I was reviewing some time back, and they include reviews of students, right? So when they present PowerPoint slides. I said, throw out your PowerPoint slide. There's a blackboard, take a chalk. Now explain what you're doing. Actually, they couldn't. I mean, some of them did brilliantly, but a lot of them couldn't. And so without that, the scaffold of the data and jargon, can I throw all of that out and in simple terms explain the essence of what I'm doing? So in my center now we have started that. No more PowerPoint, no more slides, just blackboard and that. Because that's a challenge, And unless we can do that, we can't communicate. Because you talk to your friend in let's say who's doing a humanities course, he or she will get irritated by you because we use jargon so much. We use, without recognizing it, there's so much technical constraint, we use so much technical language. We assume that they understand the principles of what we're talking about, and it's a challenge. I mean, So some time back I recruited a mathematician in my group, and I was talking to him because we wanted him to analyze data in cellular mechanisms. So I was giving him a lecture about signaling mechanisms or whatever. So after an hour he asked me, can I ask you a question? So he said yes. He said, tell me, is a cell inside a protein or is a protein inside a cell, right? So I was completely off track, right? So in a sense, the essence of the philosophy of what we do, can we communicate that?
Yes.
And I think particularly for us experimental scientists, or I can certainly speak for biologists, I won't speak for physicists here. We are so comforted by the jargon and the technical detail. Yeah. The essence of what we are doing, I doubt if any student can actually communicate that. I mean, there are obviously exceptions, but, or even our, people at our level, all PIs, So, then how are you going to communicate the value of science to somebody else when I don't know it myself? You know.
I was thinking of the other aspect of what you were saying, which is that apart from the utilitarian aspect of science, science is important because it can do so and so. What would be the other aspect in the sense that are we speaking of a certain kind of temperament that you would want to inculcate in people, which a certain way of looking at the world? You said it's questioning or doubting.
Yes, very much.
So how do we do that? I mean, that's an idealistic endpoint. Yeah. So from a government point of view, the value don't just fund science that benefits me, but let's just support science on the whole. But the other aspect is very important, and at least in India we don't have the intermediates of science journalists. We have a couple, but not many, and because that needs a professional breed of community. But I guess if you start sharing the excitement of science and so on, in simple terms, that's the whole thing. That could slowly bring people on, because already you're loaded with information nowadays, right? Your Facebook keeps you busy most of the day. You don't have time for but somehow it's like I always think of these, what is this old this Chandamama kind of stories. I mean, what I mean is that level of communication.
Beatrix Potter, the first one to work with fungi. I mean, her drawings, her every single sporule and things about fungi. What she knew was much more than what was known in the fungal biology. It wasn't even a science at that time when she grew them at home, and she was probably the first women scientist to have ever done such detailed work, because she was also and she drew them, and her books are beautiful to just look at the life forms that she's built with fungi there. So yeah, so that is the kind of...
I mean, and another thing that's happening increasingly in philosophy is that, and as Sarita also knows, I mean, the concepts from biology have completely transformed social science. I mean, because, the obsession with individual subject, I mean, most social science begins with these traditional idealistic notions, right? And people are completely, I mean, all the terms and categories, notions of surface, notions of flow, all these things have completely transformed the way one looks at social life. So in some sense it's not, I think there's already a space for that kind of comparison. We're not talking about two different planets.
Right. But again, the converse is, social sciences, information theory, they're beginning to dominate biology, right? Because now you talk about dynamic networks, I always...
biology.
Yeah, so when I talk to people, I always say proteins are people, which is actually true, because proteins function in different contexts, right? So we are a network here, right? And the dynamics of this is different. The moment we break up sub-networks, relative importance changes. I'm father in one network, son in another network. And proteins exactly, when the human genome was sequenced, we felt insulted. We had so few genes compared to even something like a yeast, right? But it turns out we still have the complexity because proteins multitask, exactly like you and me do. And it's a fabulous analogy. And again, a lot of it is information flow issues. When you talk about cell responding to a stimulus, you have these networks of molecules, sensors on top, output processors in the nucleus. So a lot of it actually is information theory. And you have this bow tie architecture that information transfer networks have, and so on. So I mean, this is fabulous convergence now. And that's why it becomes more important to get out and think in terms of simple empirical ideas that link. And so you had that question, how important is our upbringing for this? So I'd love to have a debate. I don't know how much time, but my view is upbringing is crucial, because if you're brought up to be confident, you can actually answer questions confidently, think confidently.
You believe in pedigree. You don't believe in somebody.
Not pedigree. No, it's got nothing to do. No.
Being able to do good science.
No, it's not pedigree. But most of us are brought up to be pampered, right? And we don't have the confidence to step out into the real world in many ways. You need a secure, even, at middle age, your mother is still pampering, please take it lightly, yeah? But, that confidence, which then evolves into confidence to challenging established notions, and confidence to be uncertain, to be confident in your uncertainty, is all a fundamental, so in that sense, perhaps it matters. Yeah. So maybe you'll know better, I guess.
You always come to my